All right, continuing on with lesson 12, which is like starting with rational expressions. Well, what happens if you need to multiply or divide rational expressions, right? We have these two fractions, we're multiplying them together. Now, in general, when you're multiplying fractions, the idea is just to, multiply across. And in general, there's two kind of options in when you're wanting to multiply across. Option one, I don't like as much, but sometimes it works. So I'm gonna say option one. One way we can do problems like this is just multiply immediately. Immediately. So I know fractions are scary, but either way, when you have, oopsies, 5x over 9 times 3 over x squared, we can just multiply the tops, multiply the bottoms, 5x times 3, 15x, 9 times x squared, 9x squared, and then work with how do we simplify that from there? It looks like one fraction now, so we can just work on it. You can when in doubt write it out. 15x over 9 times x times x. I see I can cancel one of my x's, right? The 15 and the 9 are both divisible by 3, so I can divide by 3 on top and bottom here. 15 divided by 3 is 5. 9 divided by 3 is 3. We still have an x remaining. Okay, that's as simplified as it gets. Really, the idea is simplifying as much as possible when we can. What I like to do, option two, leave everything factored. Leave factored and cancel first. So what does that look like in a problem like this? 5x over 9 times 3 over x squared. I can view this as x times x on the denominator for that 3 over x squared. I know these are combining eventually, but even though they're two different fractions, I can just look at them as one right away and think, how do things cancel here? Well, I have a 3 on the numerator and a 9 on the denominator. Yeah, they're at different spots here, but really, I can view this as one entire bottom and one entire top. The 3 and the 9 can be reduced to be 3 and 1, right? We can like kind of like divide by 3 on top and bottom on those two parts here. Divide by 3, divided by 3. I have a 3 left on this one and a 1 left on that one. And also I see an x cancels as well. And I'm left with what on the top? 5 times 1 or 5. 3 times 1x remaining or 3x. Now, it might seem like, man, that was a little bit tougher to see on this because I did kind of like all the canceling at once. But I think once it's a bigger problem, this actually becomes a cleaner process. So let's actually look at a couple of ways of doing this. And I'm going to be doing option two always here, just because that's just be my style, right? So what do I have here? I'm not going to combine to one fraction first. I'm just going to cancel first. I see a term like this, and I see terms on the top here. What can cancel? Well, I see that I have this squared on top and this on the bottom, so that just kind of cancels entirely, right? And I see I have an x and an x squared, so one of those cancels as well, right? If I wrote this x squared as x times x, right? One of those x's would cancel. I'm going to leave it as, the way I do it is I look at the squared and one of those x's cancels. So I'm left with just a single x remaining. So what do I have on the numerator now? On the numerator, I haven't canceled my 6. There's still a 2x plus 3y I haven't canceled. And on the denominator, I have a 5 still. Bing, bada, boom. That's how I would do this problem here. And, work on it from there, right? So not much to do in problems like this. When problems do need some more work is when you actually need to factor everything. So everything starts with like, this is the new principle we're thinking of, canceling things and combining the fractions together. And now we're going to do a problem where you need to factor first, then you cancel things and factor together. So this one I see is a difference of squares, right? Look up difference of squares or a prior video on what it means to be a difference of squares here. And this one looks like it factors. So I can do the factor game. So I'll do the factor game first. I put 4 on the top, 5 on the bottom. What multiplies to become 4 and adds to become 5, 4 and 1. So let's kind of just go straight to this next stage here where I have difference of squares. That is z minus 1, z plus 1 over z cubed times 8 over, and now this is going to be the factored version. This is z plus 4, z plus 1. What can I do? How can I cancel things or simplify things? Well, chicka chicka yeah yeah, I see I can cancel a z plus 1 on top and bottom, right? I don't think I can cancel anything else. So what am I left with at the top? I'm left with an 8 and a z minus 1. And on the bottom, I'm left with a z cubed and a z plus 4. Okay. This is really not that bad of a problem. There might be like tougher things we can do here and stuff like that as well. I'm gonna move on from the try it yourself. These are some good problems. Maybe I'll do one of these as well, like at the very end. But for now, we're just gonna move on. That is how you multiply things together, or multiply fractions together, or rational expressions together. Um, Now we're gonna get to dividing, and then maybe we'll do some more examples. Um, First, we need to talk about what a reciprocal is. Reciprocal, when I say that out loud, I mean flip your fraction. Fraction flips. So if I have some a over b, I say, what's the reciprocal of a over b? That is flipping the fraction, kind of on its head, right? B over a. Same if I have like negative a over b, well, I can look at that as b over negative a. Or because negatives can jump up and down, I can maybe make it like negative b over a. That's like another version of it as well, right? But either way, flipping the fraction means reciprocal. So think of that when we do stuff. When I say reciprocal, think flip fractions. And when I've heard of dividing fractions in my life, like you have something divided by something else, and like that's already tough in its own right. But dividing fractions, I was given like a little rhyme that helps me figure out what I need to do in that spot. And it makes it just like in a multiply problem after I apply this rule. And the rule is, or the rhyme is, when dividing fractions, don't you cry. Just flip the second and multiply. So it's okay that I didn't do many multiply examples because I'm actually going to be doing a bunch of multiply examples right now. So let's try. I see this first one is 4 over x, 3x squared divided by 2 over x squared, 2 over x. Oh no, I'm afraid of dividing by fractions. But when dividing by fractions, don't you cry, just flip the second and multiply. So let's do this one. Let's flip the second, do the reciprocal, and multiply. Okay, well, how does this cancel? I'm going to cancel before I multiply together. I see a 4 divided by 2. That becomes a 2 over 1, right? And I see an x here cancels with one of the x's on the denominator here. And I'm just left with 2 over 3x as a final answer. Okay, that's not too bad, right? So let's try this next one. I have dividing by fractions. X minus 2 over x plus 3 divided by x plus 5 over x squared minus 5, 9. When dividing fractions, don't ask why, flip the second and multiply. Times, and I do the reciprocal, I flip the second, but it's multiplied now. Well, this I can't see anything that cancels yet, but I can change this x minus 2. This is a difference of squares, right? Right? There's a formula for difference of squares. I can make this a times x minus 3, x plus 3, right? Over x plus 5. And this second, or first denominator is x plus 3. All right, anything cancel? Looks like these cancel. right? And then I'm left with whatever's left. Let's put that down lower. Why not? X minus 2, x minus 3 over x plus 5. And there we go. So not too bad of problems here. We're just looking at the like terms or the like factors that are exact. We cancel those ones and we leave the rest. We don't have to multiply it all out or anything. We could leave this as our final answer. That's totally fine. Okay, last one here. When dividing by fractions, don't ask why. Flip the second and multiply. Times, and let's flip this second here. Plus 3 over 2y. All right, this one looks a little tougher, right? It looks like I'm gonna have to do like some factoring. So let's do the factor game on this one. 3 and 4. What multiplies to become 3 and adds to become 4? That is 1 and 3. Now this one, let's do a factor game as well. -2, -1. What multiplies to be -2 and adds to be -1? That's -2 and 1. All right, so what do I got? I got y plus 3 over y minus 2, y plus 1, times, and the right side, now that I flipped it, because I don't have to worry about this dividing now, because I've already done the flipping stuff, right? This is y plus 1, y plus 3 over 2y. All right, where are the matchings, right? Where can we have matchings here? I see these cancel. Do these cancel? No, they don't. They don't cancel because they're both on the numerator here. If you have one on the numerator, one on the denominator, they balance each other out and you can cancel them both. But both on the numerator, we don't have that. But it's the same factor twice, so I can just call this y plus 3 squared. And the denominator, I have my 2y and my y minus 2. So that's just what we have. Or I could have just left it y minus 2 times 2y, but I like to order these factored parts to be like last here. And okay, that is it for this video. A little bit quicker of a video. If you want to try it yourself, you can try these ones too. This is for when I have in my class in person. But yeah, dividing by fractions and multiplying fractions together, it's usually not bad. The name of the game is just to cancel the things that you can cancel. Right? Thank you for watching.